Our story begins 4.6 billion years ago. Before the solar system even existed, there was a vast cloud of gas and dust in the region where we now are. This cloud most likely began to collapse under the influence of a nearby supernova explosion. As the sun was born at the center, the rotating disk around it gradually turned into the raw material from which the planets would form. Venus began to take shape within this disk, in a region very close to the sun. This area was extremely hot. Volatile substances, such as water, could not remain stable for long. For this reason, Venus was predisposed from the very beginning to become a planet dominated by rock and metal. Small rocky bodies, known as planetesimals, collided and merged over millions of years, forming Venus's core and mantle. This process was extremely violent. The planet's surface melted and solidified repeatedly. Venus's present-day dense structure was shaped during this early period. At this stage, Venus was remarkably similar to Earth. In fact, scientists believe that during its first few 100 million years, Venus may have been a planet very much like Earth. Venus and Earth are often referred to as sister planets. This is because their sizes, masses, and densities are very similar. Venus has a diameter about 95% that of Earth and possesses a comparable iron core. Strong scientific models suggest that in its early history, Venus may have had oceans on its surface. Water vapor was present in its atmosphere, and temperatures were much milder than they are today. However, there was a critical difference. Venus is about 30% closer to the Sun than Earth. This seemingly small difference in distance determined the planet's fate. As the amount of energy received from the Sun increased, water vapor on Venus began to accumulate more heavily in the atmosphere. Water vapor is a powerful greenhouse gas, which caused the planet to warm even further. At this point, Venus entered a path from which it was extremely difficult to turn back. The event that determined Venus's fate is known in the scientific community as the runaway greenhouse effect. As the planet warmed, its oceans evaporated. The water vapor released into the atmosphere further increased the temperature. This vicious cycle ultimately caused all liquid water on the surface to disappear. In the upper atmosphere, water vapor was broken apart by ultraviolet radiation from the sun. Hydrogen escaped into space, while oxygen was lost through chemical reactions with the surface. During the same period, intense volcanic activity began on Venus. Massive volcanoes released large amounts of carbon dioxide into the atmosphere. On Earth, this gas is regulated by oceans and the rock cycle, but on Venus, no such stabilizing mechanism remained. As a result, Venus's atmosphere transformed into an extremely dense layer composed almost entirely of carbon dioxide. Today, Venus's surface temperature averages around 460 degrees Celsius. This is hot enough to melt lead. Atmospheric pressure on Venus is about 92 times that of Earth. In practical terms, standing on Venus would be like standing nearly 900 meters below the surface of Earth's oceans. The planet's surface is largely covered with basaltic lava flows. Radar mapping shows that much of Venus's surface is relatively young, suggesting that the planet may have been resurfaced on a global scale in the past. Venus does not have plate tectonics. Instead, heat builds up within the planet and is released episodically through massive volcanic eruptions. This process ultimately sealed Venus beneath the thick, suffocating atmosphere we observe today. The formation and evolution of Venus are not only about understanding this planet alone. They also offer important clues about the future of Earth. Venus shows us this. The fate of a planet can be completely altered by very small differences in its initial conditions. If Earth were just a little closer to the Sun, perhaps instead of oceans, we would now have a surface resembling the hellish world of Venus. Today, scientists are preparing to return to Venus. New space missions will examine the planet's atmosphere, surface, and history in far greater detail. Perhaps understanding Venus does not simply mean learning about another planet, but also learning how to protect our own. And perhaps Venus is whispering its most important lesson to us. Earth may not be as resilient as you think.